Welcome students. In this video lecture, we are going to study about the classification of solids, conductors, insulators and semiconductors in the context of electrical properties. In the context of electrical properties, solids can be classified into three main types based on their ability to conduct electricity: conductors, insulators and semiconductors. Each of these categories have distinct electrical behaviors, which are crucial in various applications for electrical wirings to electronics devices. Let's explore each of them in details. First we have is conductors. Conductors are materials that allow electric current to flow through them easily. This is due to the presence of free electrons that can move freely across the material when a potential difference voltage is applied. Now let's have a look at the key characteristics of conductors. First we have no forbidden energy gap. In conductors, there is no energy gap between the conduction band and valence band. The conduction and valence energy bands overlap, which means that the electrons from the valence band can easily enter the conduction band and participate in electrical conduction. The second characteristic we have is free electrons. In conductors, free electrons are the charge carriers responsible for the conduction of electricity. These electrons are not bound to any particular atom and can move throughout the material. Third we have is high electrical conductivity. Conductors have very high electrical conductivity, typically of the order of 10 raised power 8 per ohm meter. This means they can efficiently transfer electric current. The third characteristic we have is temperature coefficient of resistance. Metallic conductors have a positive temperature coefficient of resistance, meaning that their resistance increases as the temperature increases. As the temperature rises, the thermal motion of atom causes more collisions between electrons and atoms, hindering the flow of electrons. The next characteristic we have is effect of impurities. The resistance of conductors increases due to the addition of impurities. Impurities disrupt the regular atomic arrangement, leading to more electron collision, which in turn increases resistance. Common conductors include metals such as copper, aluminum, gold, which are widely used in electrical wiring and components. The next classification of solid we have insulators. Insulators are materials that do not conduct electricity under normal conditions. This is because the electrons in insulators are tightly bound to their respective atoms, and there is no free electrons to facilitate the flow of current. Now let's have a look at key characteristics of insulators. First, large forbidden energy gap. In insulators, there is very wide forbidden energy gap between the valence band and the conduction band. Electrons in valence band cannot jump to the conduction band unless a large amount of energy is supplied. This wide energy gap is typically in the range of 6 electron volts. The second characteristic we have is no free electron available for conduction. In insulators, there are no free electrons in the conduction band, meaning that the material cannot supply the flow of current under normal conditions. Third characteristic we have is low electrical conductivity. The electrical conductivity of insulator is extremely low, typically in the range of 10 raised power minus 16 to 10 raised power minus 6 per ohm meter. This is because the electrons are tightly bound in the valence band and there are no free charge carriers available. The next characteristic we have is completely filled valence band and empty conduction band. In insulators, the valence band is completely filled with electrons, while the conduction band is completely empty. This configuration prevents electrons' movement, thus inhibiting conduction. Examples of insulator include materials such as glass, wood, paper, mica, diamond and ceramics. Plastics are another example. These materials are commonly used in situations where electrical insulation is required, such as in power cables and electronic components. The third type of solids we have are semiconductors. Semiconductors are materials that have electrical conductivity between that of conductors and insulators. They can behave as insulators at very low temperature, but at higher temperature they conduct electricity due to availability of free electrons and holes. Now let's have a look at key characteristics of semiconductors. First characteristic we have is small forbidden energy gap. In semiconductors, the forbidden energy gap between valence band and conduction band is comparatively small. For example, in germanium, the energy gap is around 0.7 electron volts, while in silicon, it is around 1.1 electron volts. This small gap allows electrons to jump from valence band to the conduction band when a small amount of energy is provided, such as heat. The next characteristic we have is moderate electrical conductivity. The electrical conductivity in semiconductors is typically of the range of 1 per ohm meter. Semiconductors have higher conductivity than insulators, but lower than conductors. The next property we have is conduction due to electrons and holes. In semiconductors, electrical conduction is due to movement of electrons and holes. Holes are the absence of electrons in the valence band and behave as positive charge carriers. The next characteristic we have is temperature coefficient of resistance. Unlike conductors, semiconductors have a negative temperature coefficient of resistance, meaning that their resistance decreases as the increase in temperature. As the temperature rises, more electrons gain enough energy to cross the forbidden energy gap and enters the conduction band, thus enhancing conductivity. The next we have is effect of impurities. Doping effect. The electrical properties of semiconductors can be dramatically altered by the addition of impurities, a process known as doping. Doping can increase the number of free electrons, N-type semiconductors and holes, P-type semiconductors, enhancing their conductivity. The next characteristic we have is behavior at absolute zero. At absolute zero, the conduction band in semiconductors is completely empty, and the semiconductors behave like an insulators. The most widely used semiconductors are silicon and germanium, which are essential materials in the manufacturing of electronic devices such as diodes, transistors, and integrated circuits. The chart shown in front of you is the comparison of conductors, insulators, and semiconductors between different properties. You need to remember all these properties by heart, as they are important in the preparation of entry test exam. The classification of solids into conductors, insulators, and semiconductors is fundamental in understanding the electrical properties of materials and their applications. Conductors, such as metals, allow free movement of electrons and are used in electrical wiring. Insulators prevent flow of electricity and are used for safety and insulations. Semiconductors, with their intermediate properties, are essential in electronics industry, particularly in the creation of components like transistors and diodes. Understanding the behavior of these materials is a key advancement in electrical and electronics engineering. That's all for this lecture.